Hey students, welcome back to my YouTube account. What we're doing today is we're just going over some revision questions for Year 9, particularly for the half-yearly exam that is coming up. So we're going to start off with question 10, as requested by the class. And the first question is asking us to interpret this diagram into a chemical formula. So what I need to do is look at the 1, 2, 3, 4. There are white circles and there are 2 black circles. And then I need to refer to this key here on the side. So as I can see, the 4 white circles indicate a Y and the 2 black circles indicate an X. So the answer for that is X2, Y4. It's just a matter of counting the symbols and relating them back to the table. What I'll do is I'll do one more example just to make it easier for you guys. And I'll use triangles this time. So I'll do 1, 2, 3 triangles and a square in the middle. So I'll do the square equals an X and the triangle equals a Y. Obviously they're chemical formulas, so they need to be joined together as compounds. So for this one, you need to count, there are 1, 2, 3 X's, and there is 1 Y. So you can write it as X, 3, Y, and that is your answer. So that's one more activity for the question on, which is question 10. The next question, which is question 11. What information can you work out from the atomic number of an element to the protons and the electrons are in the atom? So let's just draw a sample element. I'm just going to go to the periodic table. Coming back here, let's just pick oxygen. Oxygen has an atomic number of 8 and atomic mass of 16, both of which are really relevant to this question. So what I'll do first is demonstrate the answer. Atomic number of 8, the atomic symbol is O, and the atomic mass is 16.00. So the atomic number here, which is just call this the AN, this tells us how the number of protons. This at the bottom tells us the atomic mass, meaning how heavy the element is. And the atomic mass is calculated by the number of protons plus the number of neutrons. So coming back to the question, what information can you work out from the atomic number of an element related to protons and electrons in the atom? So the atomic number already tells us the number of protons. So atomic number equals number of protons. So we kind of answered half of the question there. But the second part of the question is asking us about the electrons. So electrons, remember, we need to go back to the charge. Protons are always positively charged. Neutrons are neutral. And electrons are therefore negatively charged. Okay? Going back to the analogy I was using in my class when we first started this topic, was that anything that is positive needs to equal the number of negative elements in an atom, or different factors in an atom. So if I have 8 positive, I also need to have 8 negative. If I have 16 positive, I also need to have 16 negative. If I have 32, I need to have 32 negative as well. Okay? So that answers the question for question number 11. Question number 12 now, which is asking us, where are the metals and non-metals found in the periodic table? So this is a very, very simplistic question. And if we come back to the periodic table, which is up here, we remember that the metals are on the left-hand side. You've got the alkali metals, the alkali earth metals, the transition metals, etc. And on this side, you have the non-metals. So coming from the metalloids, which are here, and then on over here, you have non-metals. So elements such as carbon, nitrogen, oxygen, phosphorus, sulfur, and etc. And you've got the noble gases on the side. They're all non-metals. So once again, the metals are on the left, and on the right, you have the non-metals. Question number 13. Elements on the left side of the periodic table are most likely to form compounds with elements that are located where in the periodic table? So this question here is a little bit difficult to understand, but it's just telling us more about ions. And I'm just going to zoom out a little bit there, and I'm going to quickly draw up the ions. So it's telling us elements on the left-hand side are likely to join with elements on this side. So let's go back and revisit our terms of ions. So the first group tells us that these elements are +1, and then you have +2, and then you have +3, and all of these are positively charged. This group here we miss out, and then we have -3, -2, -1, and these are the noble gases, and they're not charged. They're always stable at room temperature, or they're gases at room temperature, but they're always stable because of the octets rule. Coming back to what this means though, why are elements on this side more likely to join with elements on this side? It's more about fulfilling the octets rule, which is having 8 valence electrons on the outside shell, or 8 valence electrons. So if I wanted to have the easiest example to use is always sodium chloride, the salt that we eat in food and that's present in the ocean. So we have sodium chloride, which is Na plus 1, which is Na, because it's in here now, so Na is in this group, and it is adding up with Cl minus plus Cl minus, okay, -1. So what happens is, if these two numbers, usually you have to cross each other out, and this number will go there and this one would go there, but let's not worry about that for this moment in time. We have a chemical reaction, and this makes NaCl, okay? In other words, let me just redraw this. Na plus Cl minus gives you NaCl. An element on this side of the table joined with an element on this side of the table, okay? Why did this happen? You have to think of the plus and the minus. So if I'm going to draw sodium, so Na has an atomic number of 11 protons, therefore 11 electrons, as we previously just described in the previous question. And we also have Cl with an atomic number of 17. Now we need to know why there is a +1 there and a 1 minus there. So let's just quickly draw the two elements using the electron shells. We have Na, always like to draw like this. I need to start off by drawing the first, so let's just quickly, shells. You have the first shell has 2 electrons, a maximum of 2. The second shell has a maximum of 8, and then the third has a maximum of 8 as well. So we need to have 11 electrons. So we'll start off with 1, 2. We've already filled up the first layer. We need to draw another layer. 3, 4, 5, 6, 7, 8, 9, 10. We still need one more electron because we have 11 there. We draw one more electron there, and then just going to draw it on this side, which is right there. So this is the 11th electron. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Therefore, making this number. Let's do the same for Cl. I'll give you guys a moment just to practice that. Okay, so I hope I gave you enough time to do chlorine. So chlorine, let's just start off, needs to have 17 electrons, or I've represented the electrons as X's. You can also draw them as circles as you please, but if we're doing them as X as a class, then stick to that so you don't get confused. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now I've drawn the electron shell structure of chlorine and sodium. Now, why do they need to come together? In other words, why do the pluses and the minuses need to come together? The pluses indicate something, one to give away. And remember in class we talked about the analogy where positive people give things away. Positively charged ions or elements give electrons away. Negative ones like to take them. And this all refers back to the magic number of 8 being the octet rule. So we need to have 8 electrons in valence shells, or the outside shells, in order for an element to be happy. So the easiest way that we can make this happen is if the X, remember positively charged Na+, just is combined and given to the Cl, you now have 1, 2, 3, 4, 5, 6, 7, 8 electrons in NaCl, fulfilling the octet rule. And that is why the elements on the left-hand side need to match with the elements on the right-hand side.